Planar Graph, Euler's Formula, Multigraphs, Euler Circuits. We are going to discuss about these four topics. And now non-planar graph. The diagram shown here is the non-planar graph, where since it's intersecting the two intersecting E5 and E6 two edges, the total edges here are 6, E1, E2, E3, E4 and E5 and E6, whereas E5 and E6 are the two edges which are intersecting with each other. That's why it's called as non-planar graph. The planar graph, a graph is said to be planar if there is no edge cross. So here the edge cross is here at E5 and E6, so it's called as non-planar graph. So to make a planar graph, we have to remove the edge cross. Edge cross should be removed. That means one line, intersecting line should be removed and it should be connected to the vertices. So here E5, I removed the E5 from the graph, and vertex, if we take the vertex V1, V2, V3 and V4, from the V2 to V4 I have to connect E5 since its connecting coordinates are V2 and V4. So instead of direct crossover of E5 and E6, I used V2 to V6 another path so that it will be a planar graph. Now it's Euler formula. Euler formula is we taken an example of cube where the cube has 8 vertices, and the edges are 12, E1, E2, E3, E4, E5, E6, E7, E8, E9, 10, 11 and 12. So these then comes to the faces. Here the faces are 6, up, top, up and down and right, left and 4 sides as well as up and down. So totally there are 6 faces for a cube, cuboid. So the vertices, edges and faces we have to calculate. So the vertices are 8, edges are 12 and faces are 6. The Euler formula is based on these vertex, edge and faces. So Euler formula equal to F plus V minus E equal to 2. Here F equal to 6, V equal to 8, E equal to 12. So 8 plus 6 minus 12 equal to 2. So according to the Euler formula, we got the 12 as a result. Then comes to the multigraph, a graph with multiple occurrences of the same edge is known as multigraph. See 1 and 2, 1 and 3 vertex, we have so many edges. Then comes to the Euler circuit. A walk is a graph in an alternating sequence of vertices and edges, beginning and ending with a same vertex. That means if you start from a particular vertex, we should end with the same vertex. A walk is a closed if the first vertex is the same as the last vertex. So whatever the path it is, it's a closed. From first vertex we have to go to the last vertex, and the first vertex and last vertex should be the same. Then comes to the trial Euler circuits. The Euler's path is a path by which we can visit every edge exactly once. At once we have to visit at least once. We can use the same vertex for multiple times. The Euler circuit is a special type of Euler path when the starting vertex of the Euler path is also connected with the end vertex of that path. Then it is called as the Euler circuit. So the starting vertex should be the end vertex. See here example is taken A, B, C, D. A to B we can move, B to C we can move, C to D we can move and D to A we can move. So A to B, B to C, C to D, D to A. So starting vertex is A and ending vertex is again A. So it comes under the Euler circuit.